Let's see the next topic in general science, that is motion in physics. So in this chapter, these are the important types which are generally asked in the exam. The first one is the basic of motion along with its type. Afterward, you should know the various physical quantities like distance, displacement, speed, velocity and acceleration. And the very important one, you should be very thorough in the equation of motion from where you can find few of the numericals. And finally, the graph based question. Okay. So the first question, in rectilinear motion, the object moves along what? Straight line, ellipse, parabola or circle? Student, the word itself says linear. So whenever you see the word linear, it means something it is related to the straight line. Okay, so option A, those who have given, they are right. It is rectilinear motion if object moves in straight line. In theory part, we have seen such pointers like what are the motions, what are the different type of motions. Okay, I am not going to repeat in today's session. You should know all these definitions along with the examples. Okay, let's see the next question. Which among the following is about displacement? Okay, which among the following is false about displacement? Okay, it can be positive, negative or zero. Yes, it is true. Displacement can be positive, negative, zero. The next one, displacement is never greater than distance. It is also true. Distance and displacement can become equal, but displacement is not going to be greater than distance. Okay. And displacement, as you know, it is the shortest distance. So distance is basically the unit of length should be there. It is meter. So SI unit is meter. And finally, option D is false because it is not always positive. Okay, it can be positive, negative or zero. Okay, and we have seen in our theory class what exactly is the distance and the displacement. And distance, as you know, it is the total path covered by an object. So this is my path, total path covered by an object. Displacement, it is the shortest distance from initial to final point. And the very important difference is that it is a scalar quantity, whereas it is a vector quantity. Okay, and the relation, as I told you, distance can be equal to displacement, but distance can never be greater than displacement. Why? Because displacement is the shortest distance between the two. Okay, let's see the next question. Kiran swims in 90-meter long pool. Okay, she covered 360 meter in 2 turns by swimming from one end to another and back along with the same position of straight line. Find the average velocity of Kiran. Student, don't start solving this question. This is a tricky question. Why tricky question? Because he is asking the average velocity. So if you know the definition of velocity, it is basically displacement over time. And in this case, she is coming back to the original point after 2 turns. So my displacement will become 0. So the answer will be 0 meter per second. Okay. So in exam, you should read the question properly before answering to this question. Okay. So option A is the right answer. So we have seen such pointer, the very basic one, the difference between speed and velocity. Speed is total distance by total time. Displacement by time is velocity. Okay, and velocity is a vector quantity. Why vector quantity? Because my displacement is vector, a very simple one, so it will also become vector. Okay, let's see the next question. Which of the following statement is correct about uniform acceleration? So uniform acceleration is basically the acceleration which is having the constant acceleration during the interval of time. Okay, so let's see one by one. An object moving on frictionless surface can achieve uniform acceleration. It is partially true, not totally true. Okay, so it is false. The motion of spring is an example of uniform acceleration. Again, it is false. An object moving at constant speed is an example of uniform acceleration. No, it is an example of uniform velocity. So it is also false. So we are left with option D. A freely falling object is an example of uniform acceleration. So option D is the right answer. And in the theory part, we have seen about acceleration. It is basically rate of change of velocity, change in velocity by time. And the SI unit is meter per second square. You can derive with formula. The velocity is meter per second and time is second. So it becomes meter per second square. And there are different types of acceleration like uniform acceleration, non-uniform acceleration, and retardation. So in the retardation, which is also known as negative acceleration, in which the velocity decreases with time, and the perfect example is brake. When you apply a brake, it is basically the negative acceleration. The velocity of the vehicle will start decreasing, right? Let's see the next question. If the velocity of a car increases from 5 meter per second to 10 meter per second, then what is the acceleration? So just now we have seen acceleration is change in velocity by change in time. So here velocity changes from 5 meter per second to 10 meter per second. It means the change is 5 meter per second and time is 5. So it is 1 meter per second square. Okay, so option D is the right answer. Again, one more numerical. If a trolley is moving at an acceleration of 2 meter per second square from rest, then after 4 seconds its velocity will be what? Okay, so you can use the equation of motion or the definition of acceleration. Okay, so it is basically v is equal to u plus at. Okay, here it is starting from the rest, so initial velocity will become 0. Acceleration is 2 meter per second square and time is 4, so it is 8 meter per second. Okay, so 8 meter per second, it is the right answer. Don't go with option C. It is acceleration, meter per second is velocity. Okay, so option A is the right answer. And there are other equation of motion. These top 3 are commonly asked in the exam. Okay, v is equal to u plus at, v square minus v square is equal to u square plus 2as, and s equal to ut plus half of at square. Student, you have to remember that these are only valid for uniform acceleration, and here u is the initial velocity, v is the final velocity, and a is the constant acceleration, s is the displacement measured from the starting point. Okay, let's see the next question. A car is running at uniform acceleration of 1 meter per second in 5 seconds at speed of 5 meter per second to 10 meter per second. Find the distance traveled by the car. So let's use equation of motion, which is s equal to ut plus half of at square. Okay, what is the initial velocity? Initial is 5. What is time? 5. What is acceleration? It is 1. What is time? 5. So 5 into 5, 5 square is 25. So it is 25 plus 25 by 2, it is 12.5. So it is 37.5. Okay, so those who have given option B, they are right. It is 37.5 is the distance traveled by car. Let's see the last question of this session. What does the slope of velocity time graph represent? Okay, so as you know, velocity time graph is where y-axis is velocity, t is the time axis, x-axis, and if it is a line, so you should tell what is the slope indicating in this particular graph, vt graph basically. So let's take this point and make a slope. Slope is what? This angle theta. So it is basically tan theta, which is basically, if you take it very minute, so theta is almost negligible. So in that case, this is V, this is T, perpendicular by base, so V by T. V by T is what? Acceleration. Okay, so option A is the right answer. And there are many types of graph. In fact, we have seen in theory class. I'm not going to repeat in today's session. Where we will discuss that what if it is parallel to straight line, what if it is inclined line, and what are the slopes in different graph. Okay, you should go and have all these concept in your exam. Okay.